In the winter of 1898, inside a leaky, abandoned shed in Paris, a woman was told, in no uncertain terms, that science was not a place for women. She wasn't looking for fame or wealth. She was looking for a ghost. She called it luminescence. To the naked eye, it was beautiful. A soft, ethereal glow that lit the room like a fairy tale. But she was the first to realize that this light was a scream from the very fabric of matter. This is the story of a woman who reached into the heart of the invisible, changed the world, saved millions of people with her work, and paid for it with the very marrow in her bones. Welcome to the Curious Club, where every question leads to something unbelievable, and stories that sound too crazy to be true. Subscribe to our channel and press the bell icon. This is the extraordinary story of the greatest scientist that ever lived. This is the story of Maria Sklodowska, also known as Madame Marie Curie. Maria Sklodowska was born on November 7, 1867, in Warsaw, Poland, a city under the iron grip of the Tsarist Russian rule. Her father was a physics teacher, her mother a pianist and school principal. Maria was the fifth and the youngest child to her parents. On both the paternal and maternal sides, the family had lost their property and fortunes through patriotic involvements in Polish national uprisings aimed at restoring Poland's independence. Maria's mother died of tuberculosis in May 1878, when Maria was just 10 years old. Maria began attending J. Sikorska's boarding school. Poland, under Russian occupation, had banned women from higher education. Unable to enroll in a regular institution of higher education because she was a woman, she and her sister Bronisława became involved with the clandestine Flying University, sometimes translated as Floating University, which was a Polish patriotic institution of higher learning that admitted female students. The Flying Universities were named so because they changed locations every night to evade the police. So Maria did something extraordinary. She made a deal with her sister. She would work as a governess, funding her sister's medical education in Paris. And when her sister graduated, her sister would do the same for her. She arrived in Paris in 1891. She was 24 years old. She barely had enough money for food. She lived in a tiny apartment so cold that the water in her wash basin froze overnight. She lived on bread and tea, fainting from hunger and overworking. Why? Because she had an obsession. At the Sorbonne, she changed her name to the French Marie. She graduated first in her physics degree, then first again in mathematics. She was not just surviving in a world that excluded her, she was dominating it. In 1894, she met Pierre Curie, a brilliant physicist who was immediately struck not just by her beauty, but by the sharpness of her mind. Sklodowska was looking for a larger laboratory space. He was able to find some space for Sklodowska, where she was able to begin her work. Their mutual passion for science brought them increasingly closer. They married in 1895. Their laboratory was a converted shed, which was damp, barely heated. A German chemist who visited later described it as a cross between a stable and a potato cellar. Marie didn't care. She was on the trail of something no one had ever seen before. In 1895, Wilhelm Röntgen discovered the existence of X-rays. In 1896, physicist Henri Becquerel discovered that uranium salts emitted some kind of mysterious rays that resembled X-rays in their penetrating power. Interested by these discoveries, Curie decided to look into uranium rays. Using her husband's electrometer, she discovered that uranium rays caused the air around a sample to conduct electricity. Using this technique, her first result was the finding that the activity of the uranium compounds depended only on the quantity of uranium present. She hypothesized that the radiation was not the outcome of some interaction of molecules, but must come from the atom itself. Revolutionary because, till then, the entire scientific establishment assumed the atom was static, passive, and unchanging. Marie Curie said, "What if it isn't?" So she coined the term radioactivity. Curie's systematic studies included two uranium minerals, pitchblende and chalcolite. Her electrometer showed that pitchblende was 4 times as active as uranium itself, and chalcolite twice as active. She concluded that these two minerals must contain small quantities of another substance that was far more radioactive than uranium. She began to search for additional substances that emit radiation, and by 1898, she discovered that the element thorium was also radioactive. Pierre was also intrigued by her work, so he also decided to join her. For 4 years, Marie and her husband Pierre lived in a scientific purgatory. They processed tons of pitchblende. In July 1898, Curie and her husband published a joint paper announcing the discovery of a new element, which they named polonium, in honor of her native Poland. On the 26th of December 1898, the Curies announced the discovery of a second element, which they named radium, which was based on the Latin word ray. She didn't just find an element, she unlocked a door to the subatomic age. Between 1898 and 1902, the Curies published, jointly or separately, a total of 32 scientific papers, including one that announced that, when exposed to radium, diseased, tumor-forming cells were destroyed faster than healthy cells. In 1903, Marie and Pierre Curie were awarded the Nobel Prize in Physics. Marie became the first woman in history to receive this prestigious honor. The world celebrated. But not everyone was comfortable. Some members of the Nobel Committee initially tried to exclude Marie from the prize entirely, crediting only Pierre. It was Pierre himself who insisted if Marie was not included, he would not accept. The Curies were heroes. But fate is rarely kind to heroes. On April 19, 1906, a rainy afternoon in Paris, Pierre Curie stepped off a curb and was struck by a horse-drawn wagon. He died instantly. She could have stopped. No one would have blamed her. Instead, she went back to the lab. The University of Paris offered her Pierre's professorship, making her the first female professor in the institution's 650-year history. International recognition for her work had been growing to new heights, and the Royal Swedish Academy of Sciences honored her a second time with the 1911 Nobel Prize in Chemistry, becoming the first and still one of the very few people in history to win Nobel Prizes in 2 separate sciences. During World War I, Curie recognized that wounded soldiers were best served if operated upon as soon as possible. She saw a need for field radiological centers near the front lines to assist battlefield surgeons, including to obviate amputations, when in fact limbs could be saved. After a quick study of radiology, anatomy, and automotive mechanics, she developed mobile radiography units, which came to be popularly known as petites curies, which meant little curies. She trained over 150 female technicians. It is estimated that over 1 million wounded soldiers were treated with her X-ray units. Marie later described how, at night, she and Pierre would go back to their shed, just to watch the faint bluish-green glow of the radium in the dark. The damaging effects of ionizing radiation were not known at the time of her work, which had been carried out without the safety measures later developed. She had carried test tubes containing radioactive isotopes in her pocket, and she stored them in her desk drawer, remarking on the faint light that the substances gave off in the dark. Curie was also exposed to X-rays. Marie Curie died in 1934 of aplastic anemia at the age of 66 years. Her work had quite literally consumed her. She was interred at the cemetery in Sceaux. 60 years later, in 1995, in honor of their achievements, the remains of both were transferred to the Pantheon in Paris. Their remains were sealed in a lead lining because of the radioactivity. Because of their levels of radioactive contamination, her papers from the 1890s are considered too dangerous to handle. Even her cookbooks are highly radioactive. Her papers are kept in lead-lined boxes, and those who wish to consult them must wear protective clothing and sign a waiver form. She was laughed at, dismissed, widowed, exhausted, poisoned by the very work she loved. And yet, she never stopped. Even the legendary Albert Einstein reportedly remarked that she was probably the only person who could not be corrupted by fame. 2 Nobel Prizes, 2 new elements, a revolution in physics, chemistry, and medicine. If this story moved you, hit that like button and subscribe for more stories about the extraordinary humans who shaped our world.